All right, let's do one last example just to make sure that we've got it. This polynomial is a little bit more complicated than the one we did the first time around. So here we're asked to find the equation of the tangent line. So we know that our step one of that is to start by finding the derivative. And so in my step one, I'm going to have like a smaller step one. And that smaller step one is going to be to start off by finding f of x plus h. Now in this one, it's a little more challenging. I remind you, every time we see x, we're replacing it with x plus h, but specifically with x plus h in parentheses. And that's actually super important in this case because the first x plus h is being squared, the second is being multiplied by 8 and then subtracted. So the whole thing is subtracted, which means that negative 8 gets distributed to both of the things inside there. So this becomes x squared plus 2xh plus h squared minus 8x minus 8h minus 9. Be careful, again, I repeat that this is not, we can't just distribute our power. We have to actually FOIL that thing. We're doing x plus h times x plus h. Then we stick this into our limit definition of the derivative. So f prime of x, that's our derivative notation, f prime of x is equal to the limit as h approaches 0 of f of x plus h, so that's that thing that we found in step one. So x squared plus 2xh plus h squared minus 8x minus 8h minus 9 minus f of x. And here I'm not going to put parentheses. Instead, I'm just going to immediately distribute that minus sign. So all of the signs are going to change. So instead of having minus 8x plus 9, I have plus 8x minus 9. So the minus sign in this was already distributed. And then we divide that whole thing by h. So don't forget, this is a limit. Don't forget your limit as h equals to 0. Now, my goal, I know this is going to give 0 over 0. My goal is to try to cancel out h. H is not a factor of the top yet. I have to cancel out lots of things. So I can see that x squared minus x squared is equal to 0. And then I have minus 8x plus 8x, that's also 0. And that should be a plus 9, my bad there. I just changed that sign. I'm glad I noticed that. So that's actually plus 9. That minus sign didn't get distributed there. So sorry about that sign issue. That's a plus 9. And that plus 9 gets canceled out with that minus 9. Hopefully you noticed that before I did. You gotta be careful with your signs. So one of the things that helped me to notice that here is I saw that those 9s weren't going to cancel out. And I wasn't going to have left over there for an h in every single term. And we know that we're trying to have h as a factor, so we should end up with h as a factor. So in this case, we end up with the limit as h approaches 0 of 2xh plus h squared minus 8h all over h. And notice now my h is a factor. I have an h in every single one of those things. So I can factor h out as the greatest common factor. The limit as h approaches 0, h, and I'll have 2x plus h minus 8 left over h. Goodbye, goodbye, to give me the limit as h approaches 0 of 2x plus h minus 8, and I am plugging in to h. H gets replaced with 0, and I have that my derivative is 2x minus 8. So I did that using the limit definition. Now my third step here is to plug in whatever y value we were given. And in this case, plug in whatever x value we were given. We were given that x is equal to 3. So I'm plugging in 3 to get the slope. So f prime of 3 is equal to 2 times 3 minus 8. That's 6 minus 8, which is negative 2. So this then is the slope of the curve, which is the slope of the tangent line. And that brings me to my next big step. Those were our 3 small steps inside of step 1, which is to find the y value. And we know that the y value comes not from the derivative gives us slope, but from the function itself. So now I'm doing f of my x value of 3. My function was x squared minus 8x plus 9. So this is 3 squared minus 8 times 3 plus 9, which gives me 9 minus 24 plus 9, which gives me a negative 6. So that means the point that I have here is 3, negative 6. Which brings us to our last step, which is to solve for b in our equation of a line. So I know that y is equal to ax plus b. In step 3 of that first part, I found that the slope was negative 2. So y is equal to negative 2x plus b. And now I plug in my point, 3, negative 6. So my y value is negative 6. My x value is 3. So I get negative 6 is equal to negative 6 plus b. B is equal to negative 6 plus 0, sorry, not 0, plus 6, which gives me a 0. So in this case, the equation of the tangent line is just y is equal to negative 2x. And that is my final answer. It is okay that there is no b value for the tangent line. Okay, sorry about that. The whiteboard was just taking a little time to appear. So our equation of the tangent line, y equals negative 2x. The fact that b is 0 just means that our y-intercept of that tangent line is 0, and that's totally fine. That can happen. All right, that's all. Bye.